Okay, so hello everybody, good afternoon, and welcome to the latest edition of our Virtual Tech webinar series. It's my great pleasure today to be introducing Rob Richardson, who's going to be talking about TypeScript testing. And before we dive in, I just want to have a quick word from our sponsors. So today's webinar is brought to you by LogRocket. I'm sure the majority of you watching today will have come from our blog, so you'll be familiar with the stuff that we talk about, but you might not be aware of facts that we actually have a product as well. So LogRocket's a great product for when you're building and fixing applications. It's a front-end application monitoring solution. It combines error tracking, performance monitoring, infrastructure monitoring, and web analytics all rolled into one, so all of your teams can use a single source of truth for more efficient remediation of your problems and iteration of your feature sets. In addition to this, you can integrate it into your existing backend monitoring tools. For more information, head over to logrocket.com, or you can get a personalized demo or a free account and just get a sense of what it can do for you. Now, with all of that out of the way, I'd love to welcome Rob to give his talk. And just so everybody watching knows, a recording of this will be sent to your emails, and you'll also get a link to our YouTube video where we'll be hosting the video, so you can watch it there at your convenience. And then just a quick word that we do have another webinar coming out next week, a week today, also on at 12 p.m. Eastern time. If you're interested in signing up, you can head over to this URL, or you can just Google LogRocket Meetups. It'll be the first thing that comes up. Now, with all of that out of the way, I'd like to hand over to Rob. Take it away, Rob.
Excellent. Let me click on the share button. I'm really excited that we get to talk about testing in TypeScript today. We're going to do a lot of testing of both front end and back end. We're going to take a look at integration tests, unit tests, mocking. We're going to dig in pretty deep to a lot of testing concepts here in TypeScript. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, which is why we'll head to robrich.org, robrich.org, and we'll see the slides online right now. Head to robrich.org, click on presentations, and here's scaling the testing pyramid. The slides and the code that we'll see are online right now. Achievement unlocked, woohoo! While we're here on robrich.org, I'll click on About Me and we'll see some of the things that I've done recently. I'm a Shoreline developer advocate. If you're struggling with maintaining your Kubernetes cluster, I would love to learn and help with that. Microsoft and Docker have both given me some awards, and I'm also a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver completed software to charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp, or if you'd like a GiveCamp closer to you, hit me up on email or Twitter, or find me here in the Meetup, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I do a lot with JavaScript and TypeScript. I got to work on the Gulp team in version 2 and version 3 as a core contributor. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's talk about scaling the testing pyramid in TypeScript. As we start looking at testing, what is our purpose with testing? Well, we want to be able to validate that our software works correctly, validate the bounds conditions between components, validate integration between those components. But that's not all. We also want to be able to document our code's intent and mitigate risk. The business is hoping that we can build durable software. And so unit tests really help us to be able to mitigate risk. Is it cheaper for us to fix production? Or is it cheaper for us to ensure that that doesn't happen in production by writing tests? Now we have a lot of different types of tests. We can do unit tests, integration tests, end-to-end tests. This is definitely not an exhaustive list, but as we look at this list, we can see that end-to-end tests are slower and unit tests are faster. So we'll probably build less end-to-end tests and more unit tests. We want to fail fast and we want our test suite to run quickly. So we'll do a few end-to-end tests to validate critical behaviors, and we'll do lots of unit tests to be able to validate our components and validate that they render correctly and calculate correctly. So we end up with a pyramid not that unlike this, where we have a few end-to-end tests here at the top, and we have lots of unit tests at the bottom. Well, if you've ever seen this pyramid before and compared it to what you might have, maybe you have something like this instead, where we have a few unit tests, a few more integration tests, and a whole lot of manual tests. Hey, have you run through the entire website since I made that code fix? Validated I didn't break anything else? That's not really an efficient use of our time, but yet that's oftentimes what we end up with. Really, we want to aim for this. There is a place for manual testing, and that's great for penetration testing, for discovery, for bounds conditions. We want to be able to test the weird pieces manually, but we want to be able to automate a lot of the normal validation. Computers are cheaper than people. They're more consistent. Computers don't get distracted or need to take a lunch break. So ultimately, if we can build automated tests to do this, we'll probably get more consistent and reliable and cheaper results out of our tests. So we're building websites. We're building progressive web apps, PWAs, or single page applications, SPAs. So how is this testing pyramid different if we're inside of a browser? Well, we'll have some additional types of tests. Pardon me. We have our standard unit integration and end-to-end tests, but we also have things like, well, let's unit test this function. Let's just validate that it works. Now, the cool part here is there's no user interaction here. We're just running tests. We could test a component. Now, we're unit testing the component, so we'll probably either mock dependencies or we might choose to render those dependencies. But ultimately, we need to mount this component within our framework to be able to run the tests. We want to test that it works in this browser. Now that we have HTML5 browsers, this is less of a concern, but does it work in that one? Do I have appropriate fallbacks in case that feature doesn't exist in that browser? That can be really helpful. Now, these aren't integration tests, these are unit tests, but let's launch these unit tests in a particular browser to validate that these unit tests work in that environment. By comparison, oftentimes when we're running unit tests, we'll just run them in Node, which is okay, but that's not a browser. Test this API. Now, what's interesting here, we might have a GraphQL or a REST API or a gRPC API, and well, it's not meant to be consumed by humans. So we can just fire requests at it and see that we get the correct response. We don't even need a browser in this case. And then we have end-to-end tests, where we can simulate user behaviors, click on buttons, navigate through our website, and these can be really effective in validating that the entire site works correctly. Perhaps we build smoke tests this way, or perhaps we build a suite of tests that validate the critical functions within our application. So what tools might we use? Well, here's the slide that I built that ultimately turned into this talk. As we look at each of these components, we will use different tools for these tasks. Now, we'll want to accomplish all of these tasks, so we'll use a lot of these tools. Now, some of the tools are different depending on the different UI framework or backend framework that we use. But ultimately, these tools are really helpful in being able to test the various components. And we'll get to see most all of these today. As you grab these slides from robrich.org, you can click on each of these blue links to learn more about the particular frameworks. So for unit testing, we might use Mocha with Chai or Jest. For integration tests or for unit testing in a particular browser, we'll use Karma to be able to launch our Mocha or Jest tests inside that browser. Test utils gives us a great mechanism for being able to mount our components given our particular framework. And there's a test utils for each SPA framework. Supertest or Axios is great for running API tests. And if we're using Axios in our client, building our API tests in Axios just makes sense. And then end-to-end tests. We'll see Cypress today, but there are other choices as well. Now, a moment about Mocha and Chai, Mocha with Chai or Jest or Jasmine. Ultimately, these are just different frameworks that for the most part do the same task of validating our application. They include an assertion framework, they include a test framework and a test runner. The majority of the difference between them is With Mocha with try, we have expect.to.equal. And with Jest or Jasmine, we have expect.tobe. That's it. So whichever one that you like, whichever preference you like, lean into that and continue with that framework. I have no opinions about whether you should choose Jest or Mocha. We're going to use TypeScript here. Now, we could definitely use all of these tools with JavaScript, and they work just fine, but we're choosing to include TypeScript here because mocking with TypeScript is a little weird. We do need to satisfy the interface for TypeScript, and so getting our mocks to satisfy that interface allows us to use some unique packages for mocking. So mocking. There are mocks, there are stubs, there are fakes. All of these are great concepts, and later over a beverage, let's debate the differences. But in this case, I'll just kind of lump them all into the term mocks. Mocks are great because we can replace expensive external dependencies with cheaper, faster dependencies that we have more control over. If we want to, for example, call out into our API, maybe we're calling Square or Twilio, we don't want to send money or send a message. We just want to validate that our software behaves correctly given a particular response. So we'll create a mock response, maybe an error response, and now we'll be able to validate that our software works correctly given those bound conditions. It's excellent. Now, we could choose to mock out every use of our API, and ultimately that would create a really elegant mechanism where we can live in this fictitious world and believe that the API really will reply that way. We probably need a mix of mocked unit tests and integration tests using the real API to validate that we're really getting results in that same format. If ever the real API changes, we need to modify our mocks to suit. So here's a lot of tools that we'll get to see today. And what's really fun is we'll get to see each of these types of tests as we run through our browser app. So let's dig in. All of the code is online right now on GitHub. And if we head off to GitHub, we can see this application. We have a front end and a back end, and a DevOps pipeline. I've launched this application. Here's my Redis data store. Here's my backend. Here's my front end. Actually, here's my backend, and that's my front end. So let's use this application. Now, I've intentionally chosen an application that has pretty light business logic, just so that we can see enough complexity to do stuff, but not enough that it's too much for us to be able to understand. So in this game, once we've completed this 3 in a row, we can't click on any of the other squares. We also can't change a vote. We can't go out of turn. And we have a leaderboard that keeps track of who won and who lost. Let's click New Game. And if we go for a game that, if we go for a game that doesn't win, which, by the way, is harder than it looks, then we can see that there is no winner and our tie increases. So here's our game. Let's take a look at the application of how we built this. Well, in our front end, we have this app.view, and that will render our board. Inside app.view, we also have our game loop that will be able to run through each of the processes, and it will render particular components. So we have our leaderboard, and this leaderboard component doesn't actually get its own data. Rather, the data gets injected into it. We'll see how that makes testing this component really easy. Ultimately, we have an API that goes and grabs that data from our component will go grab that data from this API. So here we're using Axios to just go grab it. And we also have this scores on our backend. We have this scores API that just goes and grabs the scores and ultimately returns those to the front end, or we can update the score, telling us which player won. Now, this just calls into a backend data store that will do that content, persist that content into our data store. So let's build a test. Now, I'm going to start with this empty project so that we can build up some tests. Let's build up a new test. I'm going to say this is hello world.ts. And now how do we build up a test? It should pass. Here's this test, and our goal is time to first it. And so let's do this. Assert, we'll pull that in, not from console, but from assert. And assert true equals true, reason. Here's our test. And now if we come to the command line and run this test, npm test, we can see that our test passes. Time to first it, really fast. We can build one unit test really quickly to be able to validate our system. Now, in this case, we didn't use a whole lot of external libraries. We just used the built-in things. But here in this project, I do have Jest installed. So when I run my npm test, it actually just launches Jest. And so we can modify this test a little bit to be able to use Jest. Jest has the expect, and I like that. So let's expect true to be true. Now, I love this format, this expect and to be, because I spent a really long time trying to validate that those two things were the same. Let me undo this, and I'll show you the other syntax. In this old one, we expect true to be true. Well, which one is expected? Which one is actual? And that's awkward. I spent a really long time trying to debug a test, and I was like, but in the debugger, I get the expected result. Well, I had flipped these two values, and so I was validating that the result of the test was the result of the test, not what I expected my test to be. So separating these two can be really helpful. Now, generally, we'll also want to group our tests. Let's create a describe block, and this will be hello world. And now here in this group of tests, we can implement all of the unit tests associated with this realm. Cool. So now we have a bunch of tests. Now I want to write some more tests. I'm going to say it should add 2 + 3. Okay. Here in this test, we'll look at the arrange, act, assert pattern. Arrange, act, assert. Now this is really elegant. In the arrange step, we can set up the condition that makes this happen. In the act step, we can actually do it, call into our suite under test and validate and run the process. And then in our assert, we can validate that we've got that end result. So I want const actual equals x plus y. And then in assert, I will say expect actual to be expected. Excellent. Now that I've got my act and my assert set up, now I know what I need to arrange. Well, I need to arrange a const x equals 2, const y equals 3, const expected equals 5. Now, why did I choose to add 2 and 3 rather than say 2 and 2? Well, if I did 2 and 2, I can expect this to be 4. But what if my function actually did times instead of add? I wouldn't know. And so I've very specifically chosen conditions that I know will yield a unique result with add. Okay, arrange, act, assert. Now, what if I want to test that it can add big numbers or fractions too? So 2,000 and 3,000. Well, what we see is that the majority of our test is duplicated. So do we refactor this? Do we make this more dry? Well, part of the goal of our tests is to be able to document our system. If we do lots of layers of indirection and keeping our tests dry, then we may supplant that goal of keeping our tests as documentation for our system. Let's make our tests as simple as possible to be able to explain the topic at hand. In this case, I'm going to choose not to make my tests dry so that I can document the intent of my system. Okay, so let's run some tests, npm test, and now we get our 3 passing tests. That was cool. We got to experience the arrange, act, assert pattern. We got to time to first it. Oh, reason. It doesn't like reason there. Let's remove that. And now we'll get passing tests. Part of what's really elegant here is it tells us exactly the line number, it tells us exactly what's wrong, and so it's really quick to be able to get back to the problem at hand. Okay, so now let's return to our application. Well, here in our application, what are the things that we might want to test? Well, we want to test what a win looks like. Is that a win? We want to be able to test that our components render correctly. Does it show the correct numbers here, given data that it pulls in? We may want to be able to test that it renders the correct thing. We want to be able to test that it can reach the data endpoint, and we want to be able to make sure that the entire game works correctly. So we saw lots of different pieces of tests. Let's take a look at the code and how that works. So we have our app, and it has various components that it pulls in. It has the game loop where it goes and grabs the scores from the server and validates that if it wins, then it updates the score. If it doesn't win, check to see if it's a stalemate, and then ultimately go to the next turn. So let's test this. Well, one of the things that we wanted to test was this, where is it? Check win. Here's that function where we go check to see if we win. Here's all the win conditions. We'll take in a list of squares, and we'll validate that those squares may have a win condition. And if so, we'll return the fact that it is a win. How might we test this? Well, in this case, we don't need an integration test. We don't need any mocks. We just need to fire some tests at this function and validate that we get the correct results. So I've got a list of players. Here's how my board is built out. And then let's run test. Run test will, in this case, go turn those players into squares, hand that to my check win function, and validate that the winner is what I expect. So here I've got this board, which I think should be an X win. We've got this board that I think should be an O win. We've got this board where it should be a stalemate, and this board, which is completely empty. Now, yeah, this array is not formatted the way I might have an array formatted previously, but it really elegantly documents the needs of my system. That really looks like a board, and I can quickly see how my test performs. So we've got a test without any mocks or dependencies. It's just a strict unit test. We fire details at our function and validate that the results are as we expect. Let's take a look at our leaderboard component. Now, our leaderboard component here will just render the content on the page. Now, it's not doing any calculations, it's just validating things. But if we're testing it here, we want to be able to validate that it renders correctly. We're going to need to pull in test utils. Now, in this case, I'm using Vue, so we'll use Vue test utils, and that will allow us to mount our component. So let's mount our leaderboard component. We'll pass in the props that we need, and then we can go grab the text. Now, if I have an empty scoreboard list here, I would expect this to just include the text leaderboard and clear scores. So as we can see here in this, I just go grab that complete text, and it says leaderboard and clear scores. Yes, there's some markup there. There's angle brackets, but I've just chosen to grab the text, not the angle brackets. Next, let's pass in a list of scores. Now, I made sure that all of these scores are different so that we can validate that it's rendering correctly. And now I'm going to go grab that text and validate that it contains tie is 1. Now, if I had this as 13, then I might get the wrong answer. So I've very specifically chosen single digits here. So I validate that my component renders correctly given no data and given data. I chose to mount it using Vue test utils to be able to get it in place in my application. Now, in my application, I want to go validate that I can get and post data out of my API. In this case, this is an integration test against my route. Oh, actually, nope, we flipped to the back end, and this is a unit test for our API. Now, here in the back end, we know that that score get method is a little bit weird. Now, yeah, I could have gone and gotten my Redis inside the get scores method, but I kind of like that I yanked this out of my Express app. And if I don't get scores, I render my default score. So I don't really care what Redis is. I don't really care what get scores is. The purpose of this test is to say if get scores returns something, use it. And if not, use the default score. So I want to be able to mock out Redis. I want to be able to mock out these imported functions. So let's take a look at how we might do that. So I've chosen to pull in TS AutoMock, which is great for being able to mock very large objects where I only care about a few of them. And TS mock imports is great because I can mock my imports. Now, one of the quirks of TS mock imports is I have to import star as the thing so that I can be able to replace that particular function. And I need to do that before I pull in my regular thing, so that when my regular thing goes and reaches into that dependency, it will get my mocked dependency and not the real dependency. So let's do that. Now I want to set up my get scores. I've chosen to move this to an external method so that I can focus in on the content of my test. My test only fills up one screen. So here's my scores, and I can see that I expect my database to return blank. Now, how did I do that? Well, let's go grab the get scores method off of this score data. We'll replace it with the results of this Redis score. Now, in this case, this Redis score is undefined, and so we have no results coming out of that get score method. Let's set up the default scores. Here's the defaults. And so now I want to go make that request. Now, what's interesting about this get score data is that I'm not passing in the score. I'm passing in this request and this response. Well, those objects are pretty big inside of Express. So how might we change that? Well, I'm going to go grab this. Let's create a mock request and response. And I'm using TS AutoMock for this. TS AutoMock can go create a mock. In this case, I'm creating a Redis client. I don't care what that Redis client is. I just needed to satisfy this Redis client interface. So then I'm going to create a mock request. Now, we saw in our code how we needed an app property, and we needed a get function within it that returned that Redis mock. So we'll create this partial of t, pass that into create mock, and now we have a request. Now, TS AutoMock is going to fill in the rest of the properties associated with this TypeScript interface to ensure that it behaves the way that we expect. So there's that request. And here's our response, where we again pass in a partial of t, in this case, a partial of response, and we just grab this JSON function. Here in our application, we're not returning the results. Rather, we're calling res.json to be able to set the results. So in our test, we need to do exactly that. Let's create this JSON function, and we'll just call this callback so that you can, in your test, capture the value that it was returned. And we'll return this in case you happen to chain the method. Back in our test, let's take a look at how that works. So now that we've got a fake request and response, we can call into that get method. Now notice that we're not creating an API request. This is a unit test. We're just calling that get method on our score class. Once we've gotten done with that get method, now it'll probably call into our callback so that we can save off the score that got saved. Now let's expect scores to be the defaults. We don't want it to be our database saved result because the database saved result was blank. We want it to use the defaults. So here in our test, we were able to validate that when get scores returns undefined, then it uses the default score instead. By comparison, here in our score get, we can take a look at what if we have Redis scores and defaults. Notice how these values are very different. We'll set up those two things. We'll set up the mock request. We'll call into our get, and we validate that our scores are our Redis scores, not the defaults. We were able to validate the other side of that code. Now, we did need to do quite a lot of mocking in this case. Might it be more effective for us to rewrite this method and move this logic into another method that we can just test without mocks? Maybe. Or in this case, it was fun to be able to experience TS AutoMocks and TS mock imports to be able to validate that we can mock out those expensive dependencies to be able to get the things done. Now, in this case, this was a unit test on our back end to be able to validate those things. Let's also take a look at an integration test on our back end. Now, in this case, for our integration test, we want to fire out that API/score API. So let's go get the scores. We'll post some scores and we'll validate that they are different. Now, this get scores method, arguably this is a separate test unto itself, but the test needs to run in a particular sequence so that we can validate that we've changed. So let's do the get scores method. Well, we'll just go make a request. Request comes from supertest. Now, supertest is a great way to just fire requests at an API. And so now that we've got that request in place, we'll just create an instance of our app. And now we'll get /API/score. That response should be a score or undefined. And we'll expect that score to be truthy. Now, we don't know what the current values in the data store are, so we can't know what we should assume. We just know that it is a score object. So we could validate that, for example, it has an X property and a Y property and a ties property, or X and O and ties. But in this case, we just validated it was truthy. Now that we've returned our scores out of this get scores method, we're going to go change it. So I've got player X that I want to win. And so let's post scores. We'll pass in our app and our player. We'll go post to /API/score, passing in our player. And we expect this result to be truthy. We'll return it again. So we've kind of done 2 integration tests here, but I'm going to do a third test straight away to be able to go grab the initial scores, the updated scores, and I'll validate that I changed those scores by 1. Only X changed by 1, but O and tie did not change. So I kind of now have a third integration test for my API. Now, one of the important things to do here in API tests is to validate that we've accomplished a task, but also not to leave our external connections hanging. So I've very carefully here grabbed the Redis client out of my Express app, and after all the tests, I'm going to quit that connection. If ever you've run your unit tests and they've just been hanging out there for a good long time and they all passed, but your test suite hasn't ended yet, you probably have a database connection that isn't closed correctly. So I've actually modified my Express startup app to be a function that will return that app so that I can use it here in tests. Now, you may just do this straight in your app, but because I've done it here in this in this function, now I can initialize my app and I can close it correctly when my tests are done. Now, this is kind of a integration test from the server's perspective. We can also do an integration test from the client's perspective. Now, in this case, the client really doesn't know what the server does. So the client will just fire requests at it. Now, this client needs to assume that the server is running. Okay, we'll come back to that one, but we'll just fire requests. Here's that test. We saw that before. But in this case, because our client is running Axios, we'll just run these tests with Axios as well. So let's go to that base URL /API/score and go grab the score. We will update the score for this player. In this case, the player was X. And then once we've gotten the previous and updated results, we'll go do that math to validate that our system worked as expected. Now, this is an integration test, an API test. This assumes that that API is running. Now, how did we solve that? Well, here inside package.json, we rig up the various tests that we want to run. So here's the API and end-to-end tests. We'll run test API and test end-to-end. Test API is the one that runs that API test. We have a very specific jest config that knows where those tests are. And then end-to-end tests will actually launch Vue CLI service, which runs Cypress. That's excellent. And so here we have our test API and end-to-end. And as we start those, we'll actually set this base URL. And start server and test is great, where we'll start our API. We will launch our API here. And then once it's available on port 3000, we'll run that test API and end-to-end. Those need the API running. And so we'll start that API on our way in. We're also doing a test unit, where we just go after those unit tests. So end-to-end tests. Let's take a look at our Cypress setup. Here's our Cypress content. And so we start off with our Cypress.json. That tells us where our Cypress tests are. And then inside that Cypress setup, we'll see where everything else is. I've chosen to move my videos, screenshots, and results into the results folder. That way I can .gitignore that results folder, and I won't accidentally check in those results. But it specifies where the other directories are. In later versions of Cypress, this actually gets combined into that cypress.json. And then I have my unit tests. So here's my application integration test, my end-to-end test. I'll start off by visiting that site URL, and I've specified it here in my cypress.json, what my base URL is. So in my tests, I only need to say it starts with /. That's really elegant. Now I don't need to hard code in the URL in all of my tests. So let's go visit the site. I always like to start off a Cypress test this way. Just go visit the page and validate that my URL is that page. This is perfect to be able to validate that, well, we didn't 301 to a different page. We didn't move that page out of the way. So just validating that that page is there is a really good smoke test for Cypress. Now I'm going to load the game. Let's validate that our H1 says tic-tac-toe, a good validation of we're on the correct page. And then let's start to integrate it. I'll click on cell 0, 1, 2, 5, 4, 3, and 6. And that creates that win where we saw we went across and then back. And so cell 4 should have a win. I'll win for O, and I'll also tie. This is a great way of just validating that our suite works as expected. We can run all of the tests. We can run those critical paths end to end to be able to validate our site works as expected. So let's run all of these tests. I'm going to start off by coming in here. Let's stop our backend and run npm test. This will run all of our backend tests. We have the unit tests that mocked out our dependencies. We got to see TS automock and TS mock imports do a lot to be able to replace dependencies, but also replace really heavy object imports like a request and response object inside of Express. And we can see that all of our unit and integration tests pass here in our backend. On our front end, we want to be able to run unit tests, and we want to be able to run end-to-end tests. So here we'll run package JSON. Here in test, we'll run our front-end test. We want to fail fast if we've got some failures, and we'll run our API test and our end-to-end test after launching the server first. So let's take a look at it. Looks like our unit tests are working great. That's excellent. We've got all of our front-end unit tests pass. Now let's go launch the server. Once our server is running, we'll run those API tests. We'll just fire a bunch of requests at that API. We're spinning up the API in this process, which is excellent. Once we've got the API tests in place, there's those API tests. Looks like it's running now. Then we'll fire up our end-to-end tests. Now, these end-to-end tests, we've specifically chosen to run Express in headless mode. So we'll, because we're running in headless mode, it won't actually fire up a browser. It will just launch the browser behind the scenes. And so here's our end-to-end test. Now we're launching our, we've already launched our backend, but as part of launching Cypress, we'll also launch our front end. So in a minute, we'll see Vue start up with the CLI. There we go. And now we'll start running our end-to-end tests against Vue. Now in some of the tests, it will call into the backend. So our backend is still running. That's great. Looks like there's our first test. And our test is calling into our backend. Excellent. And our test passed. Now, part of what's really elegant about Cypress is that we also get videos of this content. So as it records, as it runs that test, if a test fails, we can just pull up the video of that test run, and we can see the steps involved in making that happen. So it looks like all of those tests passed as well. Excellent. Now we were able to run front-end tests, back-end tests, unit tests, integration tests, mocked tests. How might we run this inside of a DevOps pipeline? Well, we saw how npm test was just able to do the things for both front-end and back-end. So here in this repository, let's pull up our GitHub Actions build. Now I have this kick off on the main branch, but I also have workflow dispatch so that we can push a particular button and get it to launch as well. I'll launch Redis in the background as a service and map its port into place so that we can use it as localhost 6379. And then I'll very specifically set up that database connection as environment variables that my application expects. Next, I'm going to go into the API folder. Let's npm install, npm run build, npm run test. And I'm specifically testing the API first because I know that those tests will run faster. And if it fails fast, now I learn more. If our backend works as expected, let's go into our front end. Now, in this case, I'm using an older version of Vue, so I do need to put in legacy peer depths until this dependency is merged. Then I'll run npm run build, npm test. And so I've been able to validate both my front end and back end. npm test will kick off both unit tests, API tests, and integration tests. So back in our GitHub repository, we can now take a look at that build. Let's come into actions. And every time we make a code change, we can see that it will do all of those steps. So let's take a look at the build results here. npm build and test. Much like we saw the output of our result on the console, we can see that we're running all of those unit tests and integration tests on the back end. All of those passed. Now we're running unit tests and integration tests on our front end. It's going to give us details about our bundled content. That's excellent. Now we'll run our unit tests on the front end. Then we'll run our integration, our API tests on the front end. And finally, we'll run our Cypress tests on the front end as well. And so there's our Cypress test, and we can see that all of our tests passed. Now, that's great. We got a completely green build, and we got to see all of the results of that build. So that was a lot of fun. We got to dig into this app and get to see unit tests, integration tests, front-end tests, back-end tests. We got to see mocking when it was necessary, and we also got to see how we chose not to mock in some places to avoid giving us a false sense of security. That was a lot of tests. We got to see unit testing. We used Jest for this. We mocked dependencies with TS Automock. We mocked imports with TS Mock Imports. We test components with test utils. We did API tests with Axios. And we did end-to-end tests with Cypress. And we did all of this in our DevOps build with GitHub Actions. We saw all of these tools coming together to be able to run tests in all of the places of our application. Now, we did run a lot of tests, but we didn't necessarily run every test we possibly could create. There are other forms of testing we might want to explore. Maybe we want to do performance tests, static analysis, validate that our UI didn't change. Maybe we want to validate other form factors, text browsers, accessibility, low vision contrast. This standard is actually really excellent, so click through here to learn more about it. We can do security scans and fuzz testing, exploratory testing, and those manual tests to be able to go find those weird pieces. There's a lot more that we could choose to test with this, but ultimately, we were able to build up these tests. Coming back to our testing pyramid, let's take a look at this. We wanted lots of unit tests, a little bit of integration tests, and very few end-to-end tests. With our unit tests, we saw that we were mostly using fake dependencies. We were mocking out those dependencies to be able to get at focusing on just that unit, fail fast. And then with our integration tests and end-to-end tests, we were using real dependencies. We want to be able to validate that we're calling into that service correctly, or that we're using both the front end and the back end together. As we looked at the types of tests we built, here's when we use those tools. We used Jest as our unit test framework in most all of our tests. As we started towards the end of our unit tests, we wanted to use TS mock imports and TS automock to be able to replace some of those dependencies with the details with the artificial details that we had more control over. As we went into integration tests, we chose to use supertest on our backend and Axios on our front end to be able to fire requests at our content and validate that it behaves as expected. And then when we got to end-to-end tests, we chose Cypress as our test framework to be able to run those tests as a user would in our browser. We did a lot with validating the behaviors and boundaries between our system. We know that our system will play the game correctly. We know that if a user were to click on a particular thing, they would land on the correct spot. But there's other purposes of tests, and we saw those as well. We want to document our code's intent. We very specifically didn't refactor our test to be super dry because we wanted to be able to document our code's intent. We also ensured that if there was a lot going on, for example, setting up the mock, we did that in a small method so that we could focus on making our test really explain the concept of what we were setting up and validate it. Our code's intent is documented in our tests. And so if we have really good and clear and helpful tests, we can point new users at those tests as documentation of how the system works. If ever we change our mind about how the system would work, then we can go to those tests and update our assumptions. And we also use tests for risk mitigation. Now, if our system doesn't have a whole lot of risk, maybe tests aren't an effective use of our time, and it's easier just to fix production. But if a production outage will cost us a lot of money or a lot of user concern, then creating these tests allows us to mitigate that risk. We can be able to write code to validate our system behaves correctly. And if ever we end up with a production outage, let's go write another test to validate that that failure can never happen again. Some best practices in our tests. The test should be simpler than the implementation. It's really easy to accidentally copy and paste the implementation into a test, and that's not a good solution. Make the test a really simple case so that we can understand that in a really elegant way. We use the arrange, act, and assert pattern. This is a really good way to be able to set up the conditions for our test, run the test suite, and validate that our code behaved as expected. You notice how when we wrote it the first time, we created our act first, we created our assert second, and then we arranged the things to be able to make that condition happen. If you can write your test in that way, then you probably won't have a lot of extraneous setup. If you do end up with a lot of extraneous setup, that may mean that you have more dependencies than you need, or that your code is more complex than it should be. See if refactoring your code might make that code a little bit more effective to test. We also ran our fast tests first. We ran our unit tests first so that if we found a failure, we could fail fast and not even bother running some of the bigger tests. Now, depending on the length of our build, we might choose to continue running the tests even if our fast ones fail to be able to get a complete picture of the system. But ultimately, if we found a failure in our really descriptive unit tests, maybe we need to fix that first before we start looking at our integration and end-to-end tests. We noticed that when we were doing our integration tests with our backend, we needed to not leave that database connection open. It would be really easy for us to run our tests, have all of our tests pass, and then have our test suite time out. If that's the case, if you found that condition, you probably left a database connection open. So in our integration tests in the backend, we very specifically closed the database connection after our tests ran. And we want to be able to aim for about 10 minutes or better. If our unit tests and integration tests and end-to-end tests and performance tests and regression tests take longer than 10 minutes, then the developer may have moved on to the next task. And once the build failure comes in, well, now I need to change context again. If we can make our tests run really fast within 10 minutes, then maybe the user just jumped up to grab a cup of coffee or a cup of tea. And ultimately, we're able to stay on task, get the build corrected, and ultimately be more productive. Now, some tests, exhaustive tests, may run overnight. So maybe those do take longer. But let's pick those few that we need to be able to validate that our system is behaving as expected, maybe leaving out some of the corner and edge cases. to be able to get under that 10-minute window. Ultimately, we build tests to be able to migrate risk within our organization. Now, if you're doing a hobby project or if you're doing a low risk project, it might be easier to go fix production instead of writing tests. But if we're building an enterprise application, it can be really effective to make our tests run successfully. Now, ultimately, if our production system is down and it's costing us, say, $40,000 a minute, the 10 minutes to run our integration tests may not be worth it. We might need to skip our tests to get this build out the door so that we're not losing $40,000 a minute. In most cases, though, you don't want to jump around your tests. You want your tests to be able to validate that your system works correctly. But ultimately, we want to take a very pragmatic view. Our goal is to reduce risk. And if the risk is greater than the tests, then the tests have documented themselves. But if we need to move fast, let's step out of the test for a minute and let's just deploy to production to get our system back online. This was fun to be able to dig into all kinds of different types of tests within our website. And we saw how easy it was even to get started. Time to first it, really fast. Whether you choose to use Mocha or Jest or something else, I would invite you to write your first test, get it into your DevOps pipeline. It's so much easier to write the second test once the first one is there, and getting started is really easy. You can do this. The slides and the code for this session are online right now at robrich.org. For those of you watching on demand, find me on Twitter and let's continue the conversation. But for those of us who are here live in this LogRocket webinar, what are your thoughts? What are your questions? Which test did you like? Which test should we add to this?
That was great, Rob. Thank you so much for your excellent presentation. To those of you watching and anyone wondering, we will include any additional materials that we can in the post-webinar meetup, or post-webinar meetup email. So don't worry about that. Thank you, Rob, for your presentation. You were talking about alternative testing tools. I wonder if you could just go into a little bit more detail on that.
Most definitely. One of the fights that we like to get into is, should we use Mocha or Jest? And I hope I steered around that at the beginning, where ultimately the Mocha and Jest both really satisfy the same goal. As we get deeper into it, we might learn that we have preferences for one or the other. But ultimately, that is not a deal breaker decision. Another one where we looked at alternate test tools was we chose Cypress as our end-to-end test framework. But we could choose Selenium, we could choose Test Cafe, we could choose Puppeteer. And so whether you have experience or preferences in that realm, definitely choose the tool that makes you happy. I'm really not here to try and sell you on my tool chain, but rather expose you to the various types of tests. And so hopefully you can use the tools that I used as search results to help you find the tool that really makes you happy. Ultimately, whether that's Cypress or Mocha or test utils or something completely different, I hope you leverage these types of methodologies and discover the tools that make you happy and productive.
We do actually have a question from a participant here, Rob. Wouldn't you want tests mocking the database, the DB?
Yes, we did want to mock the database. And in this case, because I had a very specific data access tier, this DB right here, this data, I was able to mock this class instead of mocking the database directly. And that actually made it a little bit easier. This interface for getting into the Redis client can be a little bit hairy. And so faking that out was kind of intense. Instead, I just chose to fake out this entire get scores method, and that helped me accomplish that task. I agree, you do want to mock out expensive resources. Maybe that's an API, maybe that's a database, maybe that's an external API that might cost you money or interact with your customers. So mock out those external APIs, and if you can wrap them in a repository like this, it might be cheaper or easier just to mock out your repository instead? Great question.
And then another question here, just excuse me, just if you're working in a team environment, how do you make sure that people are writing the right amount of tests to the correct proportion? I presume
Good call. How do we
testing
make
is
sure that we're writing enough tests or tests in the right categories? Ultimately, I think it's a balance between build speed and scenario coverage. One of the ways that we usually look to validate this is with code coverage. And code coverage is kind of a problematic metric. It's a lagging metric, and it validates whether a test has run this line of code. That doesn't tell us if we validated all the scenarios within our application. It only validates that it ran that particular line of code. So though code coverage is super easy to measure, I would argue that it isn't a very meaningful metric. Now, if you have 0% code coverage, that may tell you a lot. But if you have 80% code coverage, 90%, that might be sufficient. By comparison, if you have 100% code coverage, what that tells me is that you're really good at gaming your tests. That may not be effective. So how do you find the right balance of tests? I find peer reviews can be really helpful for this. And part of it is your skill as a developer, as an artisan here. You'll kind of develop a gut feel of, yeah, these are the tests that I want to be able to build, and these will help me validate my system is complete. In cases where you find a production outage or you find a bug in production, that can be a good hint that maybe you might want to consider additional tests.
Okay, I think that's about all the questions we can do in our allotted time. So I'd just like to thank Rob once again for coming on today and giving a fantastic presentation. And to those of you watching, just a reminder again that the recording will be sent after the conclusion of this webinar. Just like to thank everybody for coming along and watching this morning and for asking your questions. And thank you once again to Rob, and wishing everybody a great day.
Thanks for coming, everyone. This was so much fun.
Thank you, Rob. Bye-bye.